Hi everyone, this is Sherry from Meta. Today, my coworker Tina and I are going to talk about a multi-year journey that revolutionarily changed how Meta is managing demand and efficiency for multi-tenant services. It is through a portal called Demand Efficiency Portal. Personally, I have been in Meta for more than 5 years, always been in the same team. What attracted me the most is how broad this demand efficiency space is. I started by working on automatic regression detection and triaging systems, then went into the broader demand efficiency management space. End of last year, I switched to a manager role to support the space. So today, before we dive into the details, let's first look back to 2017 and let's walk through the 5-year journey together. One of the key values of Meta is to move fast. In 2017, in order to deliver feature launches in a faster speed, Web introduced continuous push. So what that means is instead of one release per week, we're now having multiple releases per day. With the increase of number of releases, the number of regressions, meaning the inefficiencies of using resources, also increased. So to manage that amount of regressions being landed, we developed this automatic regression detection and root causing system. In 2018, Meta continues to grow in a very fast speed, and we have more and more developers on each shared platform. For example, for Web tier, we have thousands of hack developers, and they're landing tens of thousands of code changes per day, plus thousands of experiment changes. However, the web efficiency team only have 5 people. So that makes managing the efficiency of web tier more and more challenging. That was the time we introduced quota management to hold teams accountable for their own resource usage. In 2019, to further cut the cost of infra spend, the efficiency goals for those shared services become more severe. So that's the time we realized only doing defensive work is not enough. We need to be more proactive in managing those resource usage. So we created this optimization framework to surface potential opportunities and suggestions to feature developers, as well as we created an admission control to approve or reject new use cases based on how they're performing against quota. At the same time, Tina's team, which only had 5 people, were asked to manage 8 large multi-tenant services. So the independent management for each multi-tenant service did not scale. We need something that can go across those multi-tenant services. That was the time we two teams decided to collaborate together and build this one-stop shop demand efficiency portal to manage demand and efficiency across those multi-tenant services. And the journey continues until now. Next, I will hand over to Tina and she will talk about the challenges of demand efficiency management for multi-tenant services.
Thanks, Sherry. Hello, everyone. This is Tina. Just a little bit about myself. I had worked in demand and efficiency management space in Meta for 6 years. The reason why I had stayed for quite long in this space is because I kept getting excited about to solve all those challenges and see all those evolutionary changes our solution brings up. This is today's agenda. I'll directly jump into the challenges we've seen. In order to manage demand and efficiency in a scalable and effective way, we've seen a couple of challenges. The first one is multi-tenant services has its unique challenge in terms of how to attribute the cost to its user and hold them accountable, especially for interwoven social graph services. The social data, including shares, comments, has been used across multiple features. It's pretty hard to find the actual ownership for each function and the data. Moreover, some of our features are actually shared platform, including notification framework, logging framework. We have to dig deeper in order to find out the actual ownership for those shared platform costs. In addition, like what Sherry mentioned previously, due to continuous push, thousands of code changes and feature gets rolled out each day. It becomes extremely hard to find out the exact code changes which cause the demand regression. In addition, the urgency of effective demand and efficiency management got added when COVID hit us because it caused increase in user traffic and the supply shortage. Last but not least, the scalability becomes one of the main challenges in this space, which I'm going to elaborate more in the following two slides. This diagram has two sides. The left side basically is a list of infra services, including the key value, ZPDB, the social graph cache service tau. The right side is a list of product team, including Instagram, ads, video, multi-feeds. For the infra services, in order to prevent their own service run out of capacity, they have to do independent demand management by rebuilding various customized tooling, which wasted lots of valuable engineering resource. Moreover, they have to engage with hundreds of product teams to ask them to manage their own product demand. It's pretty hard to find a POC using bottom-up strategy and do effective demand and efficiency management, because usually those POC's efforts might not get recognized by their product leadership. On the product side, they also get overwhelmed by getting reached out by numerous infra services to be asked to manage their own individual service demand. They got siloed knowledge about this space due to fragmented tooling and measurement. It's pretty hard for them to get a holistic view of their infra cost and do corresponding prioritization based on ROI. In order to get rid of this N by N, high operational overhead, we really need a central process and tooling to scale it out so that product team can treat various infra services virtually as one service to manage the overall demand. On the process side, we leverage unified federated model to scale it out. This basically use top-down strategy to find a POC to manage the overall demand across multiple services. For example, there will be a VP POC to manage the demand for the whole Facebook app. And then that VP POC, we're going to find the corresponding directors to manage demand for their sub-org, product org, such as newsfeeds, video, search. And those directors will further distribute their responsibility downward to be more scalable and effective. Next, I'm going to pass it to Sherry to talk about the tooling solution, demand and efficiency portal. Thank you.
Thanks, Tina. Now let's dive into the structure of DEP. The foundation of DEP is unified product attribution and unified cost. Unified product attribution means to attribute cost to the same set of entities. Unified cost means to use the same unit to express the cost. With those two together, we are able to get a product team's cost across multi-tenant services. Then we have quota manager, which is used to assign and manage quotas. And when there is situations of teams go exceeding their quota, some quota enforcement will kick in, and that also includes admission control, which might say, oh, you go over quota, we cannot approve the new use case request. Besides, we also have two ways to support the demand efficiency management, which is through regressions and optimizations. In the end, we have enforcement piece like throttling the request. Here is the overall view. In the middle, you can see a time series chart, which shows you the trend of usage against quota. At bottom, there is a breakdown table. Currently, in the picture, it is showing a breakdown by services. So you can see how each service is performing their usage against their quota. Of course, you can also break down by product teams and organizations. So you will see how one team is using their resources across multiple services. Click at one row in the service breakdown table. Then you will see this per service view. At the bottom, the breakdown of how each organization is using the service and how they are performing against the assigned quota. Now, let's talk more details into how the unified product attribution enables the views above. We first assign cost to on-cost and then aggregate them through teams and organizations. For some multi-tenant services, this is straightforward. We just need to assign ownership for each tenant, and that's it. However, it can be very challenging for some services like graph services, because a lot of its cost is very intertwined. Let's take web as an example. On the web tier, one tenant you can think about is endpoints or those URLs. However, at meta scale, one endpoint can be used to support many more detailed features. It would be very hard for one team to manage those large endpoints. Even you think about a next level of granularity, which is function level, it's still pretty tricky because one team can create one function and that function can be used by many other teams. So in the end, we landed this combination of ownership model from the endpoint ownership plus call stacks based ownership. So how do you assign ownership to call stacks? First, we need to find those positions that the ownership change. Let's look at a concrete example. If we have functions A calling to function B calling to function C, and function A is a feed function belong to on-call A, function B and C are groups functions and belonging to on-call B. So the ownership of this call stack should be an agreement between on-call A and on-call B based on who is at the best position to optimize the cost. Let's say if the cost usually changes based on how feed ranks those posts, then on-call A should take the ownership. If the cost usually changes based on how groups implement or edit their features, then on-call B should take the cost. Once we get the alignment, we instrument the code with those ownership and retrieving those ownerships back during profiling time. With the attribution, then we can assign quota to organizations and teams based on their usage and their predicted growth, as well as constrained by total supplies that we have. Each organization can further break down their quota to teams and give them sub-quotas. We also support quota transfers between teams or automatically movement of quota when reorgs happen. Next, let's talk about some different ways to manage resource usage. First is admission control. It is a decision engine that decides if a new use case can be approved or rejected based on some rules. For example, if asking for capacity less than a certain amount, automatically approve the new use case request. Otherwise, request some manual review of it. For another example, automatically reject new use cases if a team already used all of their assigned quotas. And regression is another way to manage resource. For regressions, it is powered by our automatic regression detection and root causing system called FBDetect. It finds regressions based on steady change of usage time series, on fine granularity entities like function levels, and then root cause it to code changes or experiments rollouts. In the picture, you can see a list of regressions owned by a specific organization. On the offensive side, we built a rule-based optimization framework to surface out potential candidates that can be optimized. For example, if some use case haven't had traffic for some certain amount of time, then we can suggest to delete it. Another example is if we find some expensive web CPU functions and the input and output does not change during one request, then we can suggest to maybe memoize it. Before this framework, efficiency are mostly done by those experts in the company, and we only had a very few of them. Now we're capturing the knowledge from those efficiency experts and translate it into something that's very actionable to even a developer without efficiency knowledge or background before. So this is very helpful to attract more people to work on the efficiency work with us together. And last, to close the loop of optimization management, we built Efficiency Hero to record wins. We use it to collect efficiency wins and bring recognition to win contributors by surfacing these wins to org leaders. This helped to create an environment that encourages more and more people to join us and work on the efficiency together. With all of this, I hope this is helpful. And next, I will hand over to Tina to wrap it up and talk about very exciting impact and future plans.
Thank you, Sherry. After Sherry has shared what is demand and efficiency portal, next I'll close it out with the impact and future. As for impact, currently DEP has covered 30% of Meta footprint. 17 infra services gets onboarded into DEP without spending extra efforts to rebuild the tool. Most importantly, it influenced product team to start having efficiency mindset, which means they start to care more about the cost instead of purely business impact during development. In the past 3 years, we've seen 5x efficiency win gets landed by both infra and product team. As for future, currently, Efficiency Hero has been leveraged to be used as a company-wide tool for efficiency award nomination. We use it to systematically track all efficiency wins across Meta and reward the top efficiency contributor during performance review. In addition, some of the component of DEP has been used for general efficiency management beyond the demand efficiency. This includes service efficiency and utilization efficiency for fleet and etc. At last, DEP also help the ROI-driven budget allocation, which has become the top priority in Meta this year. This will enable Meta to maximize the business impact within limited capacity budget, so that the company can operate cost effectively, which is crucial under current challenging economic environments. That's all for our talks. Thank you for listening.